All right. Well, hello everyone. I think we're live here. So yeah, I'd like to welcome you all to this short live session on building applications on EKS and Cassandra. I'm Aaron from DataStax, and I'll be taking you through the material today. So hopefully, if there's a lot of you out there who are running your own Cassandra, self-managed, maybe you have it in the cloud. You can absolutely use some of the things I'm going to show you today to kind of help you build out further in the cloud into with your application layer that'll talk to either Cassandra, DSE, or whatever you happen to be running. All right, let's go here. So real quick, it's just going to look like this. We're going to be, oh, I wonder if I can, no, I can't move my picture around. That's okay. Anyway, so we're going to go through a quick intro, talk a little bit about the architecture or stack that we're going to use today. We're going to talk a little bit about the data API. And for those of you who have used Cassandra and DSE before, and maybe you've used it for a while, you're probably used to connecting via CQL. Well, the data API is this cool new thing that really kind of simplifies the process. And then finally, I'm going to take us through a quick demo of building out a Java application and putting that Java application out there in AWS right along with my cluster. So, all right. And hopefully it'll all work. I was just telling Michelle that I went totally scorched earth on everything I built. So this is all being rebuilt from notes. So you can see it happen live. So this should be really cool if it works. All right. So real quick definition of terms. So we throw a lot of abbreviations around there of, especially with some Amazon services, like EKS for Elastic Kubernetes Service, not to be confused with ECS, Elastic Container Service, which is Amazon's service that, if you don't need full-blown Kubernetes, it's a way to run a containerized application out in your Amazon cloud. And of course, if you want to run a container image out there, you need to have that container image in a container registry, which is where Amazon ECR or Elastic Container Registry comes into play. So those are our three definitions that will be thrown around a bit today. So EKS is, Elastic Kubernetes, ECS is Elastic Container Service, and ECR is the container registry. All right, just so we're all clear on that. So real quick about the architecture. One thing that we've been focusing on a lot lately with self-managed Cassandra out in AWS is that, we have this notion of DataStax Mission Control, which is our product that, helps abstract away Kubernetes. It puts Kubernetes on easy mode, where it really helps you out. So it runs on top of Amazon EKS. And then inside of Mission Control, we can decide, hey, maybe I want to deploy a Cassandra cluster. Maybe I want to deploy a DataStax Enterprise cluster. Maybe I even want to deploy that new hyperconverged database or an HCD cluster. You can do all that really easily and seamlessly with DataStax Mission Control. The additional piece that we're adding in today, though, is that, hey, so I've got my cluster out there. How do I do something with it? How do I build an application that talks to my DataStax Enterprise or Cassandra cluster? Well, that is actually going to be stood up on Amazon ECS. So, again, just so we have a, clear view of the stack and of the architecture, this is kind of going to be our goal for today. All right. I've talked a little bit about the data API. Oh, man, my picture is really in a bad spot there. Let me just kill that for a second. Can I do that? No, I can't do that. Oh, I can. Hey, no, don't do that. Can I say, no, that's actually somewhat better. Let's stick with that for a little bit here. Sorry, we have a new streaming tool that I've never gone live with before, so we're kind of learning as we go. Anyway, so data API. When you deploy a enterprise grade DataStax cluster with it, so DSE 6.9 or HCD 1.0, you automatically get a pod deployed for the data API. So that's actually really cool. Is that when you go ahead and you build out one of those clusters, you don't have to worry about standing up the data API. And in addition to it, it's just kind of there. So really easy to use. Now, again, I mentioned that, for those of you who have used, enterprise grade Cassandra or regular Apache Cassandra before for a while, you're probably used to connecting to the CQL binary protocol and using drivers that are designed to, use that protocol as well. And that's on port 9042. Well, this one, the data API, connects on port 8181. So this is just a little bit of a reminder that you do need to expose that port, for the data API as well, just to make sure that you're able to connect on it. Now, shifting from CQL to the data API does have a little bit of a change in how we name things. A key space becomes a namespace, a table becomes a collection, a row becomes a document. If you want to get even further, like a column or a cell becomes a property. So that's just how you hear me kind of refer to things going forward. Just in case I happen to throw around key space and namespace without really explaining why I'm using one or the other. Just note that that the switch between the two ways to connect to your cluster kind of brings along that little change in definition of terms. All right, so connecting with the data API is super simple. All you really need is an endpoint and a token, and you can build your token with a quick command in Kubernetes that I'm going to show you actually, and that's just this kube control get secret. And then you specify, like the name of your user, your namespace, and then you do a -o for out, and you send it as a format of YAML, and you're going to come back with the 64-bit encoded representations of your username and password. Then to build your token, you start with the string of Cassandra with a capital C, and then a colon, and then the 64-bit encoded username, and then your 64-bit encoded password. So it ends up looking something kind of like that. But again, I will show you this process. Super easy. And then, of course, when you go ahead and connect up, because it's like REST, it's a REST-based connection. You'll actually send the token along as a header variable. So that will allow you to connect up, and we'll actually put this to use in just a little bit. So the demo application that we're going to build today is this application called DS Books, and the idea is that hey, we have these books that have been written by DataStax employees. So we're just going to we're going to build an application that lets us like list them out, catalog them. Maybe even do a little bit of like easy searching by like title or author. And the stack that we're going to use for this, of course, on the back end, we're using Cassandra or DataStax Enterprise. The controller layer is built out with using Spring Boot, and then Vaadin actually allows us to kind of build really quickly, just in pure Java, a component-based GUI front end for the web. So those are the three things that we're using to put our application together. Now, of course, we have an all-new driver for this that allows you to work with the data API. It's the same one actually that we use for AsterDB. So it's just AsterDB-Java. Then you can specify the version. And again, depending on which dependency manager you're using for Java, whether you're using Maven or Gradle, you'll want to go ahead and put the dependencies in, obviously to whichever flavor of dependency manager you're using. I tend to use Maven, so I'm going to be using the top one in my POM XML. But for those of you who love Gradle, the dependency is right on the bottom there. So there you go. All right, now for the fun part. Okay, so we got our demo. We're going to start out by just by having a look at our load balancer. It already does exist. I've actually, that's one of the things that I didn't blow away for this presentation. So I left the load balancer intact, but we'll just go ahead and take a look at it with kube control. Then we're going to build out our, it says DS albums. I should say DS books. We're going to build out our DS books app. We're going to build it into a Docker container. and then push that container out to Amazon ECR, and then use that container to create a new service inside of Amazon ECS. All right, here we go. Let's put the rubber to the road and just see what we can do here. So I'll switch back to picture-in-picture here. I think that's going to be better. So hey, this is mission control, and you can see I have a cluster out here called Roll Bones. This is running on DataStax Enterprise, so DSE 6.9.2. We have 3 nodes out there, and this is all running in, as you can kind of see from if you can see my URL here, it's all running out in US West 2. So if I want to be able to see like Kubernetes-based resources and assets, this cluster, I can go ahead and bring up a terminal window here, and we can just say kube control. Oh, let's see. Let's do actually, you know what? Let's just do a get pods. Yeah, and this is inside my own Aaron's Proj namespace. So let's just start with that. And as you can see, here we go. We have a pod running out there for SQL Shell. We have another one running out there for the Data API. We have another one for Cassandra Reaper, which kind of manages our consistency-based repairs. And then we have a pod for each of the nodes, 0, 1, and 2. So there are all of our pods out there. So now let's modify this just a little bit. And maybe I want to do a get services. And let's just make sure we're pulling back, say grep roll the bones. And then we'll pipe that to grep one more time to just pull back anything that has the load balancer type. Oh, I may want to run the command grep. Yes, that would be good. Okay, so we pulled back 2 load balancers here. As you can see, the CQL service has a load balancer on it. And I've also defined one for the Data API. And as you can see, it has an internal IP, but it also has this DNS entry here. And we're going to make a note of that because that is going to be our connection endpoint that we'll use for the Data API. And of course, that's running on port 8181, just kind of like we mentioned. So now that we know that's out there, let's go to Postman. So in Postman here, again, I have that DNS entry that leads to our load balancer. We're gonna specify our default namespace on the end. You know, when you're working with key spaces inside of Cassandra for CQL, you can really, you know, name it whatever you want. You know, some of the things that we've used and that we've built for a lot of our Gen AI applications, like if you've seen any of the videos that our awesome DevRel team has done with, you know, anything with you know, like Langflow or any of the RAG applications or anything like that. They're using, a lot of times those drivers will have a default namespace named default namespace. So just to avoid confusion, that's what I've done here. Now, what I'm going to do is send it this create collection command, and it's going to create a collection named DS Books. And if you have a look at my headers here, you can see I've got, accept and content type of both application JSON, but I also have my full Cassandra token here, prefaced with the word token. So I should just be able to go and run that. And with any luck, this is taking a little bit of time. Come on. Hey, there we go. Status okay. Outstanding. All right. So now let's move down to this this post command I have called insert many books. So now you notice I have that same DNS entry up here with the 8081 for the endpoint. We have our default namespace as our key space or namespace, but then we also have the name of the collection of DS Books on the end. That's how we're going to send all of the data in JSON format about our books into our collection. So let me go ahead and run that. And hey, I got a bunch of IDs back, so that's a good sign. If it has a success condition, it'll return the ID that it was inserted with. So let's bounce back to mission control for a second. And inside my roll the bones cluster here, I'll go to the CQL console. Okay, so let's log in as me. There we go. So now, since I'm connecting via CQL, now I'm kind of shifting back the names from like namespace and collection to key space and table, like we're kind of used to. So let's do a use default namespace. All right. Ooh. So if I have a look at the tables, yep, DS Books is one of the tables. So let's do a select star from DS Books, just like that. Hey, there we go. We have 8 rows, which it's exactly as many as we should have. So, hey, that means that our collection and our data are all in place. All right, let's switch gears. Oh, you know what? I skipped the part about the token, didn't I? All right, let me do that quick. Here I've already used the token, but I'll show you how to get that. So that's a kube control get secret, and in our case, it's going to be roll bones super user, and we're going to go ahead and grab our namespace up here, so I don't have to retype that. Then I'm just going to say YAML, just like that. Boom. And you can see right up here, we have our 64-bit encoded username and our 64-bit encoded password. So that's where our token comes from. Okay, now let's switch gears a little bit here. So if I go back to Eclipse, yes, I know I'm one of the few remaining devs on Earth who have not converted over to VS Code, but I've been using Eclipse for 15 years, and I'm not interested in changing. So let's go ahead now, and we're gonna build this out. So I've already included that dependency for the AsterDB Java driver. What I'm gonna do, since in my Java class here, I have this collection of type document defined as like a private class variable. And then above that, from the environment, I'm pulling in my application token and my endpoint. So in the controller here, let me just start by initializing my collection, or my connection, I should say. Let's do data API client. I'll just call that client, and that's going to be a new data API client. And we're going to initialize that with our static environment variable of token. Simple enough. Next, let's create a database API object. So let's just go database DB API, and we'll say client.get database. And yep, we're going to pass API endpoint, and we're also going to pass our namespace. So let's say default namespace, just like that. All right. And then we also have to initialize our collection object up here. So real quick, let's just go collection equals DB API, get collection, and we're going to pass the collection name of DS Books, just to go ahead and match what we have out there. All right. Let's see here. So we have a few methods that need to be filled out here. One of them is this just get one book. So what we're going to do is just do a return, because it's going to return a value of type optional document. So let's say collection, and we have a find. We have a find one, but we also have a find by ID. So that's what we're going to use here, and just pass book ID like that. You'll notice too that we also have like get mappings for RESTful endpoints. We're actually not going to use those today. Vaadin is actually going to go straight to the underlying methods, like the get one book that I just specified here. But you know, having those as a RESTful endpoint is a good idea to kind of offer like expandability into into your application. Oh, and I see a question here about like what roles do we need to associate with the service account? Um, I'm trying to remember how I did this all here. I don't think there was anything special that I had to do. Um, yeah, I think really the only time that I had to mess with specifying like roles for the service account was when I was creating the backups for the Cassandra cluster. But yeah, yeah. Oh, actually, yeah, there is a role that runs things on the service side in ECS, and I'll cover that when we get there. So yeah, that's a good question actually. All right. So get all books. Let's go ahead and do this one real quick. This will just be a return, and we can just do a collection find with an empty parameter list. That'll pull everything back. Now I know that you've been taught, and that I've publicly stated to many times, don't just do a select star without a where clause. When you have a result set that's as small as this for what we're doing, that's actually not terrible. So that should be okay. All right, let's do find by author. So kind of the same thing here. We're going to say return, and this is going to be collection, and this we're going to do a regular find. Now I've included the equals operator up above, so I can just do EQ, and then we want to check for the author property, and we want to make sure it's equal to the author variable that we're passing in here. Likewise, we're going to do the same thing with find by title. So I can paste that, and let's just go ahead and put title there and title there, and that should all be okay. All right, so now I've saved that, and that all looks okay. Let's go ahead and test this out quick. So if I go ahead and just do a run here, all right, looks like it started. And let's go localhost 8080. Hey, look at that. We have our application. Outstanding. Okay, let's now go to the command line here. And let me page back in my notes. I'm actually going to export my endpoint. And I'm going to... Oh, you know what? I probably don't need to do this in retrospect. So yeah, right from here, let's just go maven clean install -P production. Just do that. All right. Passing that P production for Maven actually does trigger some things in the build in terms of building out the proper dependencies into your jar file for Vaadin. So that's sort of important to do. So let me have a look at my target directory here. Okay. Yeah, you can see that this file just got built. So let's go ahead and build our application as a Docker container. So we're going to go ahead and do a Docker, and I'll say build-t. We're going to tag it as dsbooks, and we want to run this in the local directory, just like that. This might take just a second. Oh, look at that. Finished. Great. So now if I go ahead and look at my local Docker repository, you can see that I have this dsbooks entry right here as a container. So again, if this all worked, I should be able to test this out by clicking run. And yep, let's expand optional settings. We want 8080. Oh, one more. And then we also want our environment variables. So let's put our endpoint out there and our application token out there as well. And we should be able to run that. Let's have a look at containers. Oh, did that not? Oh, is this what it? No, I don't think that's... Oh, 19 seconds ago. Well, maybe it is. Well, you know what? Let's try that again. Maybe I didn't do something quite right here. All right. 8080. Yeah, we won't bother naming that. Okay, so application token. There we go. Maybe that was it. Maybe it realized that I kind of hosed up my application token there. And let's go endpoint. Okay. Oh, yeah, you know what? It might have collided with the application in my IDE that I didn't stop. Maybe that's what the problem was. Okay, now let's try running it. Hey, this looks much better. Okay. Yep, I can see that it started. Now let's go up over here. Localhost 8080 again. Hey, all right, we got our application. Outstanding, outstanding. Okay, so now I can stop this and we can go back to our command line here. So real quick, let's go ahead and we're going to need to re-tag our Docker container to match up with our ECR repository. So let me do that quick. So let's go ahead and do Docker tag DS books, and I have my my URL for our repository, or URI, that I'm going to put right here. And I'm just going to put DS books on the end of that. Okay. Now, the way that we can tell if this worked is if I go back to Docker images, and yep, you can see I have two of them for DS books, but the one with our ECR URI is at the top. So that's how we know that worked. Okay, so now let's go Docker push, and that's all we should need to do. Oh, my authorization has expired. Right. Okay, so I'm going to go ahead and do a AWS CLI login quick. We're going to use ECR, and we'll do get login password. And this is going to be for US West 2. And then Docker login username AWS password, and password standard in. We'll do that. And I think I just need our account URI on the end of that. Let's try that. Oh, I wonder if I missed something along the way. Let's try that. Hey, login succeeded. Outstanding. Okay. Now let's retry our Docker push. And have a look out here. This is the repository that I'd put together for our demos that we ran at AWS reInvent a couple of weeks ago. So we had a demo for Langflow, and then we had an AI shopping assistant that we built that was kind of using that Langflow endpoint. So if we do this right, our container for the DS Books application should show up here. Hey, all right, look at that. Okay, let's copy that URI because we are definitely going to need that. All right. So now it's in ECR. Let's go ahead and shift gears over to ECS. Oh, wrong way. Let's see here. Elastic Container Service. There we go. Okay, and then same thing inside that ECS cluster that I'd built for reInvent. You can see we have two services down here, again, for the same ones that kind of match up with the the pre-existing containers that were out there. Let's go ahead and create a new task definition. Okay, so let's say just call it DS Books. So real quick, you need to specify the operating system and architecture that that the application was built with. So I'm running on a Mac M2, which is an ARM processor for advanced RISC machine. And for those of you who don't know, RISC means reduced instruction set computer versus like what most people are used to with like most PCs are CISC or complex instruction set computers. So there you go, CISC versus RISC, and then ARM is like somewhere in the middle. All right. Point is though, I want to select Linux ARM64. Here I can select some of the resources that I want behind my service, like that. Here we go. Somebody asked before about like which role do I need here. We can actually just leave that as a blank, and it should pick the right one. But I do have this ECS task execution role that I've created that should allow this to work just fine. Okay, for the container itself, we're just going to say DS Books. Remember, I copied my image URI, so I'll just paste that in. This is indeed an essential container. All right, so we're going to go port 8080, just like that. And we need 2 environment variables. So I'm going to do this exercise again of adding both the DB API endpoint and the application token. And let's go ahead and put our data API endpoint there. And then our application token can go right here. Okay, and if I scroll down, I think the rest of this is all okay. So let's do a create. All right, so we have our task definition created. What I can do here is I can say deploy, and I can say create this task as a service. So let's say create. Yep, it's going to that ECS cluster. We're going to use Fargate as our capacity provider. I think that's our only option here. Let's see here. Yep, we're deploying our task as a service. You can also launch a task as a task, with the idea being that tasks are, I guess they're both kind of ephemeral, but a task will live for a little bit and then just be gone when it's done, whereas a service kind of endures for an extended period of time. We'll just call this DS Books. Let's see here, and then under networking. The default security group is not going to work. So you're going to want to pick an AWS security group that has port 8080 already exposed on it. I created one just for all of our demos at reInvent. And I think if I just search for reInvent, yep, sure enough, there it is. So then we have the correct security group, and I'm pretty sure the rest of this is okay. So let's do a create. All right. So now we can see our ECS cluster. We can see the services that are running. If I go ahead and I do a refresh, hey, look at that, DS Books is up here. And it's not quite running just yet. But I can click into here and I can say tasks. And if we refresh a little bit, okay, there we go. So it's provisioning. It's on its way up. I can even maybe take a look at the logs as well. Look at that. It started. Maybe we're okay here. Let's see if I do a refresh. Well, it says it's pending. It might still be waiting here. Okay, running. That's what we want to see. All right, so now if I click into the task, you'll notice it has this public IP address here. And I'm just going to copy that. And if we did everything right, 8080. Oh, look at that. Oh, it worked. I was really kind of questioning myself as to whether or not I'd put too many moving parts to be assembling live in front of you here, but it looks like it all came together. So we start off with you remember Denise Gosnell used to be our chief data officer. She wrote a book on the practitioner's guide to graph data. We have Jeff Carpenter and Patrick McFadden's cloud native data on Kubernetes. You can't go wrong with that. Actually, I have a copy of that I have a copy of both of those that I just mentioned over there as well. And of course, I could also plug Evan Hewitt and Jeff Carpenter's Cassandra Definitive Guide. And earlier this year I wrote one called Code with Java 21. So hey, if you're coding with Java 21, I advise you to check it out. Shameless plug. But yeah, so this looks like it's working. All right. Well, with that, I can bounce back over to our slides here. And here, let's maybe do that. Well, that's a little bit better. Anyway, so other resources for you to check out. Have a look at our Discord server. It's out at discord.gg/DataStax. Of course, we also have our DataStax developers YouTube channel, which this is being broadcast on, and you can find this recording at the same address on YouTube. Once it completes up. And of course, for other resources, feel free to check out datastax.com. We have plenty of material out there. Pretty much, if you're stuck on something with one of the drivers or one of the databases, or maybe you're even trying to build a RAG application with Langflow and React.js. Hey, we have all of that on our website. To all that documentation to be able to help you out. And of course, if you have questions, the Discord server, we kind of run that 24 hours. Somebody's always looking at that. So yeah, that should be about it. I'm looking to see if there are any other questions here. Oh, how can Cassandra be launched in Kubernetes pods? Well, that's a great question. The thing is, though, is that we actually do have there actually are official Docker containers of Cassandra that you can go ahead and pull down. I do recommend, if you're gonna use those, we actually did start with the when I worked at Target and we put it on Kubernetes. We did start with the community Docker container, and we just we use that as a good building point. So that's kind of what I'd recommend, because every enterprise is going to have their own requirements about how they run containers. Specifically, though, if you've looked at some of our Kubernetes-based offerings, you'll notice that we have a free and open source project out there called Cassandra, which is essentially a containerized version of Cassandra that's specifically designed to run on Kubernetes. And when you deploy through mission control, we're actually using the official Cassandra images that are getting pulled down, and that's what mission control is deploying inside of Amazon EKS. So yeah, that's a great question, actually. Let's see. I don't see too many others on here. So yeah, I guess that's let's see. Is there a Q&A side? Oh yeah, and it's just the same ones that I'd answered already. Yeah. I think we're in good shape here. So, all right. If there's nothing else, hey everyone, thanks for joining. I hope you enjoyed it. I hope you got something out of it. And best of luck in continuing to run your clusters and building out your enterprise applications on top of them. All right. Thank you.